This is How to Study for the SAT and ACT, Probability and Counting. I'm John Linneball, and I'm with John Linneball Tutoring. I'm the sole proprietor of John Linneball Tutoring, and you can reach me at johnlinneball.com. You can email me at john@johnlinneball.com. You can call me at 415-986-7355, or you can call or text me at 415-623-4251 if you have questions about this video or you're interested in tutoring. What we're covering here. What should I know about the probability for the test? What should I know about the probability for the test? What should I know about probability for the test? The probability of the test, well, I don't know. If you signed up, you're probably going to take it. Ha ha ha. Anyway, what should I know about counting for the test? What's a Venn diagram? How can it help? What about combinations and permutations? And if you like this video, please don't forget to give this a thumbs up, subscribe to my channel, and click on the little bell in the top right corner for notifications. Probability basics. Know the basics of probability. That's really all you need to know for the ACT or the SAT is just really the basics of probability. So any probability is greater than or equal to 0 and less than or equal to 1. Why? Because 0 means impossibility. It can never, ever, ever happen. 1 means certainty. In the real world, practically nothing is impossible. Even if something we know it's not going to happen, or just, yeah, like that would happen, there's some chance of it happening. I could possibly win a boxing match against Evander Holyfield or Conor McGregor. I wouldn't count on it, but let's say they're disqualified at the last minute, so they have to forfeit. So yay, I won a boxing match. But not likely to happen. And 1 means certainty. Well, okay, usually people say, well, that's as certain as the sun coming up in the morning. Well, the sun might not come up in the morning. What if it supernovas? What if it expands and swallows the Earth so we don't see it? You know, things like that. There's a lot of ways the sun might not come up in the morning, but they're all extremely unlikely. So, you know, there's a very high probability, but it's not quite 1 that the sun will come up in the morning. Anyway, the probability of something not happening is just 1 minus the probability of that thing happening. If we have something that can either happen or not happen, then we know the probability of it not happening plus the probability of it happening has to be 1. Therefore, the probability of something not happening is 1 minus the probability of that thing happening. The probability of 2 independent events happening is the probability of the first multiplied by the probability of the second. If A has a probability of 1/2, so it's a 50-50 chance, and completely unrelated event B has a probability of 1/3, the probability of both A and B happening is 1/2 times 1/3, which is equal to 1/6. So here are some more probability basics. The probability of at least one of 2 independent events, A and B, happening, so what I mean is either A happens, B happens, or A and B both happen, is going to be the probability of A, and we can represent that as P parentheses A plus P parentheses B, or we could say P of A, P of B, minus P of A times P of B. Where's that come from? I'm glad you asked. This is the probability of A times the probability of B, so that's a probability of both things happening. But it's already included in the probability of A, and it's also included in the probability of B, so if we don't subtract this out, we're going to count it twice, and we're not going to come up with the right answer. So, as I said right here, we subtract the probability of both A and B happening because it's already included in the sum of the probability of A and the probability of B. It might be easier to think of the probability of A being the probability of A and anything else, including B, and the probability of B being the probability of B and anything else, including A. So if A is the probability that I'm going to drive to work in the morning, and B is the probability that I will work out at the gym during my lunch break, well, okay. If both happen, then that's subsumed within probability of A, because it doesn't matter as long as I fulfill the conditions for A as long as I drive to work, and B I fulfill as long as I go work out at the gym. So then both of these things are fulfilled if I go to work in my car and then I go work out at the gym during my break. So then you have an overlap here in this Venn diagram, and we'll talk about that a little bit later. So we have to subtract this so we don't count it twice. Okay, hopefully I've gotten that point through. Dependent events. The probability of B happening, if it is dependent on A, that means what happens in A actually does affect B, is the probability of it happening after A happens. So the probability of pulling a black card on the second draw without replacement, that is, you don't put the first card back in the deck, you just put it in a discard pile like this here, is 25 over 51 if the first card drawn was black, but it's 26 over 51 if the first card drawn was red. And so the reason that is because, okay, if the first card drawn is red, then we know that there are still 26 black cards in the 51 that we haven't flipped over or drawn yet. But if this first card were black instead of this 9 of diamonds, then we'd say, okay, well, there's already one black card here, so we know there are only 25 more black cards in the 51 that we still haven't flipped over. So that's where the 25 over 51 and the 26 over 51 come from. So again, the probability of drawing 2 red cards as the first 2 cards without replacement is going to be 26 over 52, because half are red, half are black when we have the full deck. Then 25 over 51 is equal to 1/2, because 26 over 52 reduces to 1/2, times 25 over 51, which is 25 over 102. The probability of a black card followed by a red in the same scenario is 1/2 times 26 over 51, which is 13 over 51. So it's slightly more likely that you'll draw a black than a red card than drawing 2 reds in a row. And the same thing would work if you ask about 2 reds. Drawing 2 reds is slightly less likely than drawing a black than a red, or a red than a black, using exactly the same calculations we've just done here. Probability problems. Probability problems come in a number of different styles, and one common one on the SAT, or the ACT is something where you have a figure and part of it is shaded. We'll pretend that part of this figure is shaded. Anyway, where you have to figure out the probability of a random point being chosen from the shaded area, or a dart or some other projectile that is thrown or shot at it, hitting it. So here we have the square at right has a side length of 2. So this side is 2, that means this side is 2, this side is 2, this side is 2. What is the probability of a dart that hits within the square not also being in the circle? So we need it to hit in here, in here, in here, or in here, but not in here. So the probability is just going to be the area of the square, so this whole square, minus the area of the circle, because we don't want it to hit in there, and then you're going to divide it by the area of the square again, because that's the whole thing. So since the side is equal to the diameter, so we know if the side length is 2, that means the diameter is 2, that means this is 1, the radius is 1. So it's 2 times 2 minus pi times 1 squared, which is 4 minus pi. So the probability of the dart hitting within the square but outside the circle is 4 minus pi divided by 4, because the area of the square, which is 4, minus pi, which is the area of the circle, divided by the area of the whole figure, which is just the area of the square. So it's 4 minus pi over 4, or approximately 21.5%. The counting principle. Know it. The counting principle is a really simple idea that you should know for the SAT or the ACT, or just in general, it's a good thing to know. The counting principle says if there are X choices for one thing, such as ways to do a job, kinds of sandwiches you can have, any other thing you can choose between, and Y choices for another thing, the total number of combinations, I will enunciate combinations. Anyway, the total number of combinations you can have for both things is X times Y. This works for any number of things. The counting principle in action. So, for example, let's say a car company sells one model of pickup truck, one kind of SUV, one sedan, and one sports car. Any vehicle can be purchased in red, blue, green, black, white, or yellow. Any vehicle can be bought with a manual or automatic transmission. How many different vehicle choices does the company offer? Well, all right. So we see there are 4 different vehicles, models you can have. You can have a pickup truck, you can have an SUV, you can have a sedan or a sports car. and 6 colors, so you can have red, blue, green, black, white, or yellow, and 2 transmissions. You can either have a manual transmission, a stick shift, or you can have an automatic transmission. So, how many different vehicle choices does the company offer? Well, if we just multiply 4 models times 6 colors times 2 transmissions, which is 4 times 6 is 24, times 2 is 48. Excellent. We can use the counting principle and probability. You probably figured it out already, but in case you didn't, to determine the probability of an event, we have to figure out how likely that event is and the likelihoods of all possible events. So the probability of any given event or outcome is the probability of that outcome divided by the total number of possible outcomes, including the outcomes that we want. So let's take our vehicle example. Suppose Steve wins a contest and the prize is a randomly chosen vehicle made by the company. What is the probability the vehicle will be a yellow sports car with a manual transmission? Assume that all choices of color, model, and transmission are equally likely. And I'm sorry that there's not a question mark here instead of a period. Oh well, sue me if you don't like it. 2 ways to solve this problem. 4 models times 6 colors times 2 transmissions equal 48 different vehicle choices. Since the problem specifies that no model, color, or transmission is more likely than any other, and no, that horn beeping was not set up, that's just somebody outside beeping their horn. Anyway, since the problem specifies that no model, color, or transmission is more likely than any other, we can do this problem one way, which is just multiplying the likelihood of the vehicle being a sports car, so that's 1 out of 4, or 1/4. The likelihood of it being yellow, so that's 1 in 6, there's 6 different colors. And the likelihood of it being a manual transmission, 1 of 2, or 1/2. So it's 1/2 times 1/4, which is 1/8, times 1/6, which is 1 out of 48. Or just realize the total possible outcomes is 48 from above, and we want the probability of one outcome, so it's just 1 out of 48 since we've already said that all the outcomes are equally likely. So here are some math tips. Probability, the counting principle again. You might see the counting principle in such a problem as this. In the United States and Canada, telephone numbers are 7 digits. That is a 3-digit exchange followed by 4 additional digits. And we're not going to include area codes here, so it's just the digit and, the 3 digits that are your exchange and 4 additional digits. The town of Phonyville, see what I did there? Ha ha ha, wants to install a new phone system that follows the convention of pressing/dialing 1 before an area code for long distance and 0 for the operator. However, Phonyville doesn't follow other real-life restrictions. For example, in many areas, a phone number can't start with 911, 411, 211, 311, 811, or 555 because many of those are information services, and 555 is the fake exchange that they put in a long time ago, so the only real 555 number was 555-1212 for information. So, but I think that's been replaced with 411, but we don't care. All right, that means the first digit can only be 2 through 9, 8 digits, but the others can all be 10 digits, 0 through 9. So the total number is just going to be 8 times 10 times 10, so that's the number of exchanges. That'd be 8 times 10 times 10, which would be 800, times 10 times 10 times 10 times 10, which is 10 to the 4th, which is 10,000. Anyway, you end up with 8 times 10 to the 6. You can see 1, 2, 3, 4, 5, 6. So that's 10 to the 6. 8 times 10 to the 6, which is 8 million. So Phonyville could possibly have 8 million different phone numbers given the restrictions that I've given you in the problem. Venn diagrams. All right, we saw one before. So in case you haven't seen this before, which I know is really unlikely, but if you haven't, here's a Venn diagram. So usually they're ovals or circles that overlap, perhaps with a rectangle drawn around both. So let's have an example. There are old pilots and there are bold pilots, but there are very few old, bold pilots. So let's say we have 200 pilots total in our sample. 130 are bold and 75 are old. How can we find the number of old, bold pilots? Simple, we just add the old and the bold and say 75 plus 130, well that's 205, but we know there are only really 200 in the whole sample. Oh, I get it, there's an overlap. So the extra 5 must fall in here where they're both old and bold. So if we were adding these things together, we'd have to subtract 5 to get the 200. And it's also, we can use the total, and whatever the extra is must fall into this overlap area. Excellent. Combinations and permutations. Should you use combinations and permutations on the SAT or ACT? If you know the formulas and when to use them, you can, but I wouldn't say you should. Ooh, it says use the. Oh well. If you don't know the formulas or how to use them, you don't need to knock yourself out learning them. The counting principle will take care of any counting and probability problem. What do I mean by that? Well, combinations mean order doesn't matter. So 3, 2, 1, 2, 1, 3. If I order chicken wings and Coca-Cola at a restaurant, it doesn't matter if I say, I'd like a Coke and I'll have some wings, please, or I'd like some wings and I'll have a Coke, please. It's going to be the same order. Permutations means order matters. It probably does matter what order I do something. Like if I get dressed, I probably should get dressed after I take a shower, not get dressed then take a shower. Otherwise I'm going to be not very clean and walking around in wet clothes. So anyway, but there will always be more permutations than combinations, because if order matters, then 1, 2, 3 and 3, 2, 1, even though it has the same 3 numbers in it, those are not the same permutations, right? Or some people say a combination lock's combination is really its permutation, because it matters what order you do the combination lock in. Ha 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 ha. Okay. So permutations defined in the formula. As I said before, permutations basically means order matters. Let's take a 9-player baseball team batting order. If we want to choose 9 players from 12 on the team, we have 12, because we have 12 to choose from at the beginning. Then we only have 11, then we have 10, then we have 9, then we have 8, then we have 7, then we have 6, then we have 5, then we have 4. So we have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 possible orders. So using the counting principle. And then, of course, we have 3 times 2 times 1 that we didn't use. So another way to define this is 12 factorial over 3 factorial. Okay, and that's represented by 12 exclamation point. And no, 12 exclamation point doesn't mean a 12 I find really exciting. Hey, I've heard kids ask that after math class when I was in school or when we had to take this test. Hey, what's the difference between 12 and 12? And, it just means that it's 12 factorial, which is 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Since we don't want 3 times 2 times 1, these are the possible order of players that we didn't choose, so we divide 12 factorial by 3 factorial to get rid of the ones that we didn't choose. You can also use your calculators and subscript NPR key to calculate the number of 9-player batting orders by pressing 12, then the NPR key, then 9. Combinations defined and formula. Alright, combinations, as I've already said, means the order doesn't matter. So let's take a 9-player baseball team from 12 players at the tryouts. Let's say they're Little League tryouts, something like that. If we want to choose 9 players from the 12 of the tryouts, we can calculate the number of 9-player orders using 12 factorial over 3 factorial as stated above. But we're not done. Since ABC and CBA would be different orders but the same combinations, we have to divide the number of permutations by the number of extra permutations, that is, the other ways you could order the 9 players that would not mean a different combination, to get just the number of combinations. So 1, 2, 3, 3, 2, 1, 2, 1, 3, all the same 3 players, but we just want to count that once. So that would be 12 minus 3 factorial, or 9 factorial. So the combinations formula would be the same 12 factorial we used for the permutations, but now not only is it divided by 3 factorial to get rid of the permutations, of the 3 players that weren't chosen, we're also dividing by 9 factorial to get rid of all the extra permutations of the ones that we did choose. So you can also use your calculators NCR key, so small, subscript N, large C, subscript R, to calculate the number of 9-player teams by pressing 12 NCR 9. If this confuses you, just use the counting principle. You don't need to use any of this to do well on the ACT or the SAT. And if you don't take anything else away from this video, if you're listening to this and you're like, John, this is all gobbledygook, I don't understand anything you're saying, Please, please, please take this away from it. There is no gambling system. Anyone who tries to sell you a gambling system is lying to you and wants to take your money, especially if it is the casino telling you there is a gambling system. Okay, there's no way for you to beat the odds at the casinos in Las Vegas, Monte Carlo, Atlantic City, anywhere else. Casinos run on Native American reservations, etc. Okay, there is an exception noted for the MIT and Caltech wizards who sneak in computers, communications, equipment, etc. into hotel rooms and, whatever, radio back and forth to people on the gambling floor. Yes, there is a way to, in quotes, cheat without cheating on some games, and we're going to discuss that in just a minute. But, fine. If you're a member of the, MIT gambling club, whatever, I'm sure you're already laughing at me. Great. For the rest of you, stop laughing. This is true. All right. All casino games are set up in such a way that the casino wins most of the time, from 50, slightly more than 50% to, 99% or higher, which makes perfect sense because, if they've got to win a little bit more than half the time just to stay in business. Most casino games are random. So most casino games are based purely on chance, or in the case of slot machines, a payout schedule that's set by the casino. Casinos can make a machine loose so it pays out frequently, or tight so it pays out infrequently. If I recall correctly from things I've read online and in books, if you fly through Las Vegas and decide to play a slot machine at the airport, good luck. Those are really tight slots. They don't pay off very often. But some casinos, they really like to keep people gambling, so they're fairly loose because they want you to be paid off enough that you're like, hey, I'm having a lot of luck, I'll stay here. A game that's purely based on chance, such as a roulette wheel, is bound by the same exact rules of probability that we've already covered, okay? The rules never change. The chance of something landing on any of these spots on the roulette wheel is going to be the same every time. And that's, of course, assuming that they're fair. That is, not rigged. Again, from what I've read, at one point it was actually cheaper to buy a rigged roulette wheel in Las Vegas or wherever you might be buying a roulette wheel than to buy a fair one. But any commercial casino, Vegas, Atlantic City, again, Native American casinos, that can legally run a roulette wheel, they're not going to use rigged games because they're highly regulated. They'd get in trouble. There's no need. So you can see the book Super Casino by Pete Early. You could even just watch the movie Casino. All those things about, the book of people who are excluded and things like that. That's no joke. So, and the main takeaway here is they don't need to cheat. Probability itself will mean that they make money a lot more often than you do. So in a fair casino game, no outcome is more likely than another. A roulette wheel has 38 possible outcomes: 0, double 0, and 1 through 36. So your chances of the ball landing on any one spot you've chosen is 1 out of 38, meaning you're much more likely to lose your money than win on a given spin, assuming that you're betting on one thing. There's 37 chances to lose and only 1 to win. So slot machines, again, as I've said, are inherently rigged since the probability of a payout can be adjusted by the machine. So I know, you're probably asking, well, hey, come on. What about card games, smart guy? I can win. Well, poker depends on skill, bluffing, etc. It and similar card games are the only ones that you can control. But there's a saying, basically goes like this: every poker table has one sucker at it. If you don't know who the sucker is when you sit down, it's you. You're the sucker. So even if you're great at poker and you say, John, I always know the sucker, I'm awesome at poker, I don't know what you're talking about, that's great, but casinos can and will refuse to let you gamble if you're too good. You win too much money, they'll just say, yeah, that's great, because either they think you're cheating or they're just we don't care. You just win too much of our money. We don't have to gamble with you any more than, we can force people to come in and gamble in our casino. So what about Blackjack or 21? Well, 21 or Blackjack is another common casino game. If you've played at home, you probably know it's not that hard to count how many of each card, ace through king, has been played, and thus the likelihood of drawing a high or a low card. That helps since you want the total on the cards to be as high as possible, but it has to be 21 or less. If you go over 21, you go bust, you lose. And if the person you're playing against, the dealer, etc., gets higher than you and closer to 21, then again, you lose. So the problem is casinos deal from a shoe containing 6 or more decks of cards mixed together. Every state's gambling law requires that cards be dealt from a shoe. They have different regulations saying exactly what kind of shoe. And, it's a lot harder to count cards from 6 decks. There's going to be 24 of each card value rather than 4. So unless you have some kind of device where you can count the cards, or you can have a supercomputer, where you're radioing back and forth, you're not going to do it. If you saw the old movie Rain Man, this guy who's autistic manages to do it, and they kick him out of the casino. That's great, but okay, unless you are an, idiot savant, then you're not going to do that. So Frank Sinatra actually had an interesting experience with a shoe. You can see it, I believe, in Running Scared, The Life and Treacherous Times of Las Vegas Casino King Steve Wynn by John L. Smith. If I recall correctly, what I read in that book is Frank Sinatra got into a big argument with an Atlantic City casino dealer. He insisted, oh, come on, don't deal the cards from a shoe, just deal them to me. And she said, no, I can't do that. And a male casino co-worker saw this woman being berated by Frank Sinatra and came to her aid and may or may not have punched Frank Sinatra. I believe in the book it says he did, but in the New York Times article that I cited to here, it looks like it didn't. It was just, he was complaining that he was treated very badly by the casino staff when they're just trying to obey a law. But certainly a lot of people I've dealt with in the hospitality industry, people who are my friends who've worked as waiters and things like that, they say, yeah, you always run into somebody who wants you to break a law for them, and you can't do it. I'm sorry you can't smoke in restaurants in California. I'm sorry I can't serve you alcohol past, alcohol serving time, da-da-da-da-da. So, anyway, but I digress. 21 is the most common game that people try to beat. Since you can make fairly good gambling choices at 21/Blackjack if you count what cards have been played, people always try to count cards in those games, as I've discussed. It's also why casinos will kick you out and ban you for doing it, even though it's not really cheating. I remember playing 21 when I was a kid, and I could just count the number of cards, like, all right, we've already played 3 aces, so the chances are fairly low that this next card is an ace. So remember, casinos can choose whether to gamble with you just as they can't force you to gamble, and I suggest that you don't gamble. The MIT Blackjack team, if you're not on it, don't gamble. The only people who've gotten away with it are people with computers set up in hotel rooms with communications, radio, etc., links to the player. It was a group of MIT, Harvard, etc. students, the MIT Blackjack team, who actually did manage to cost casinos around the world a lot of money. So you can see the movies Breaking Vegas, a documentary, or 21, a fiction or based on true events movie. Based on true events means, yeah, we took something true and we made it sound a lot cooler than it really was. So, anyway, again, as I've said a couple times, if you're not an MIT or Caltech computer expert, don't count on beating a casino. Casinos are much more likely, on the other hand, to pay off than lotteries. Lotteries actually make Vegas odds look pretty good. So, state lotteries are almost impossible to win, at least the big prizes are. I know if you play Lotto and you match like 3 numbers or something, then you get $12 or something like that. Yay, that's great. But the big prizes, they're almost impossible to win. As people say, you're about 3 times more likely to be struck dead by lightning than to win the lottery. And we'll see that in just a second. So, you can consider lotteries to be a stupidity tax. Such as, win $55 million? Oh boy! Well, what's the catch? Well, the catch is, you practically can't win. California's Mega Millions, and I just got this from California Lotteries website. It's pick 5 lucky numbers from 1 to 70 and 1 mega number from 1 to 25 on a Mega Millions payslip, or play randomly generated numbers with Quick Pick. It makes no difference if you choose your own or let the computer pick them for you. I've run the numbers. I've had people say that. I have bought lottery tickets before when I had an extra dollar and felt like throwing it away. You know, some guy at a store where I was buying it said, "Did you bring your numbers with you?" I said, "Oh, no, I'm just buying a Quick Pick." "Oh, but you're a lot more likely to win if you keep playing the same number." Not really, because these events are independent. But anyway, since there are 5 numbers that can be 1 to 70 plus the mega number that can be anything from 1 to 25, there are 70 times 70 times 70 times 70 times 25 possible outcomes. So let's bring that up on my calculator here. Okay, so we're going to go 70, and we're going to take that to the 5th power. Okay, and then we're going to multiply that times 25. And okay, so we've got 500,000. Okay, so that's 17,500,000. So that's 42,017,500,000 possible outcomes. Okay, so we're going to clear that out for right now, but we'll leave the calculator up. So okay, so that's 42,017, or it's not 42,000, 42,017,500,000 possible things. So your chances of winning are roughly 1 in 42 billion. There are only about 7.5 billion people in the world, so that wouldn't be bad for a worldwide lottery. It'd actually have pretty decent odds of winning if everybody in the world played. But should I play the same numbers every time? As I just discussed, it makes no difference because each drawing is an independent event, so the odds reset every time. You're saying, well, wouldn't my chances of the numbers of winning increase over time? After all, the chances of not winning, the chances of not winning, as I said before, would be 1 minus the chance of winning. Yeah, okay, so the chances of your not winning in D drawings would be 42,017,499,999 over 42,017,500,000 to the D, where D is the number of drawings. So Mega Millions drawings are every Tuesday and Friday, which is 2 times 52 weeks a year, or 104 times per year. So let's do that. Let's try 42017. Okay. 499999. Okay, divided by 420175000. Ooh, wait a minute. Okay, 420175000. Okay, there we go. And that is equal to, all right, so you have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, before it even becomes anything other than a 9, you've got to go in 10 decimal spaces. So, all right. So let's say we play both times a week for a year. So that's 104. Okay, it's still really unlikely that you're going to win. Okay, let's say we do that. Okay, 104 times. Let's do that for 30 years. So then that would be this to the 30th power, right? Okay, so that would be... Okay, we still have a problem here. So if you play it every day for 30 years, let's make this a negative, and we're going to add that to 1, so we're subtracting it from 1. So your probability of winning if you played this for twice a week for 30 years is going to be 7.4254 blah 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 times 10 to the negative 8. Okay, 10 to the negative 1 is 1/10. So 100th. So okay. So that's about 7.42 over, times 10 to the, over about 100 million. So that's not really very good odds. So, okay, don't count on seeing that big prize no matter how often you play it. Okay, so let's move on. So if you play for a year with the same numbers, you got what I showed you there. You get roughly 2.7, 1 minus 0.9999752, which is about, times e to the 9. So it's about 2.5 out of a billion, or 10 in 4 billion, or 1 in 400 million. So only about 330 million people live in the U.S., so every U.S. citizen could play their own numbers for a year, or there might still be no winner. So the chances of winning, again, using different numbers is exactly the same. Why? For the same reason I've already told you twice, because you're still just picking one number each time, and the chance of any one number being picked is exactly the chances of any other number being picked. The chances of the same number winning, yes, you'd have to multiply that. That would be astronomically small, since it's astronomically small that you'd win for the first time, so it would be even smaller. It would be, an almost insignificant probability times another almost insignificant probability, so that'd be a really insignificant probability. That would be like the chances of being struck dead by lightning with the winning lottery ticket in your pocket and some other incredibly unlikely thing happening. I don't know. So Super Lotto Plus has only slightly better odds. The California Lottery website says pick 5 lucky numbers from 1 to 47 and 1 mega number from 1 to 27 on a Super Lotto Plus play slip. So there are 47 to the 5, because there's 5 numbers, so, and they can be 1 through 47, times 27, because there's 27 different mega numbers you could pick. And so if we do 47 to the 5th, all right, so let's go back to the calculator. Okay, so we have, not 7, 47 to the 5th. Okay, that is 345,007, so 229,345,007. Okay, and then we're going to multiply that times 27. Okay, times 27. So that's, again, 6,192,315,189 possibilities. So your chances of winning are 1 in that, so we can just actually flip it over. And it's 1.614 times e to the negative 10, so that's rough numbers, about 1.6 in 10 billion. Okay. Not great odds, if you ask me. So, okay. So it wouldn't be a great system for a worldwide lottery, but for a state with about 40 million people in it, that being California, it's pretty effective. So even if, here we have 6,192,315,189, and 189 is divided by, okay, let's try that again. 6,192,315,189 divided by 40 million is still 154,807. Okay, no, it's 154,807,879.725. So even if everyone in California bought a ticket, the odds of anyone winning would be roughly 1 in 155 million. Not great odds, if you ask me. Anyway, so please know your probability, know the counting principle, and for God's sake, don't gamble. Don't play the lottery either. Okay? People tell you the lottery. I did have someone when I worked at a convenience store and we sold scratchers and lottery tickets and stuff. I tried explaining that principle to them, and they said, "Oh no, it's not rigged. If you win, they pay you." And I'm like, yeah, I know, we paid out the small prizes from scratchers and things like that, but the odds of winning are so low that, yeah, I mean, with those odds, sure, hell, I would offer you a prize. I'd say, okay, if you can pick a number using those odds, I'll give you my brand new car, and I'll cook you a steak dinner, and I'll let you live at my house for a year with no rent and blah, 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 because I know I would never, ever have to do that. Okay. Anyway, end of lecture. Did you find this video useful? Please like it and subscribe to this channel. Neither action costs you anything, and you'll always be alerted about my new and always free videos. And also click on that bell thing to get notifications, because even though when you subscribe they should already notify you, sometimes it doesn't work. I don't know, ask the people at YouTube, I'm sure they have an explanation. Why do I care? YouTube doesn't give me any ad revenue unless I have 1,000 subscribers and 4,000 hours, which is 240,000 minutes, of view time in a year. So if you saw an ad on my channel, or during this video, or before it, after it, please know that I got nothing from that ad. This is the only way I can get any ad revenue, is if you subscribe. And, it's a way for you to help me without spending your money, because your money, basically, well, everybody's money goes into a pool that's spent on advertising. You buy a product, some of that money goes to the advertising, so it's money you're already spending. Hey, why not give me a little bit if you like this video? You know what I mean? Anyway, while many people are watching these, I don't have 4,000 hours of watch time. I don't have anywhere near 1,000 subscribers. For the same reasons, you're not only welcome, but encouraged to share links to this video, put it in playlists, etc. I'm always happy to read and respond to constructive criticism or suggestions for new videos.
I'd appreciate your input.
I reserve the right to delete comments from and block those who specialize in destructive criticism. Just my fancy language for trolls, or things that are off topics, spammers, disturb people. A lot of people, they just kind of have one-track minds and they want to post everywhere. Please don't do that on my channel. If you do, I will delete your comment. But other than that, thanks for watching. Hope you're having a good night, good day, whatever time it is when you're watching this, and talk to you later. Bye.